counting. T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11. Tower clear.
Here we got a roll program. Neil Armstrong reporting the roll and pitch program which puts Apollo 11 on proper heading. Plus 30 seconds. Roll complete and ignition program. One Bravo. One Bravo is a abort control bullet. Altitude 2 miles. Apollo 11 Houston, you're good at 1 minute. Downrange 1 mile, altitude 3, 4 miles now. Velocity 2,195 feet per second. Start model pressure red line is lit. I don't. Where? Yeah, it don't make a difference. No difference. Okay, let's punch him in. Everything just go, Ralph. We're through the reach of maximum dynamic pressure now. Yeah, it looks good here. We're 1350 at the start model. Set 8 miles downrange, 12 miles high. Velocity 4,000 feet per second. Stand by for mode 1 Charlie. Mars, mode 1 Charlie. 1 Charlie. 1 Charlie, you are taking the station status. Houston, you are go for station.
Alright, so this should be working. Turn it up a little bit, I guess. Yep, there we go. Yeah, I need to make... Why doesn't Road Connect automatically start? It's the only thing I don't like about it. Like out of all the... Yeah, and it needs to have its noise gate. I mean, it's turned on, but maybe No, the music's coming through. That's what's happening. Yeah, okay, good. Excellent. Yeah, it's still weird. Because it's still not getting rid of the noise gate completely. Let me add one here. There is a noise suppression. Let's add a noise gate. There we go. Alright, so that should get rid of the noise. On the background, I don't think I have a fan going. Perfect. So we should be live. Let me bring the social blade back up. And hopefully that noise gate's not too aggressive. So I'm just doing a little bit more work here on this replication system. So we have a shard, and oh, our scroll rect is not and we can just add more entities. What? Okay. Apparently we need to in the scroll container, layout, transform, scroll. No. Position, anchors, full rect. And then this one won't be full rect anymore. Hey, how's it going, James? I see something cool you've been looking up over the last day and a half. I'll actually show you the build, because the build is more interesting. Check this out. So this is oh, commercial? Okay. I will wait for you. Let me know when no commercial. You're back? Okay, so check this out. So I had a dream last year, and a lot of this stuff was in the dream. So this is wait, why is my audio not being relayed to me? Outside of Parsec, I swear to God. Anyway, you guys can hear the audio. I can't right now. I need to get the output audio. Is that? Anyway, so I wanted to create this replication system called Celestial, and I didn't want to change what Godot was doing with Godot's underlining code. So I started creating this boop-a-doop-a-doo. Hang on. Let me just go in and get replication spawner. Get the project open here so I can kind of demonstrate. So I started working on this this system, right? This replicator client that's going to be responsible for the glue between shards themselves. So the idea is each server is authoritative over all of its own nodes, like it would be, as if it was like not single player, but as if the server didn't have anything in existence, you know, relative to itself. And the idea, I'll just run it here, right? Is this. I have everything in the build that it needs. So first we run a replicator, and the replicator is pretty much right now a pure UDP kind of a glue solution. So it doesn't know anything about shards, it doesn't handle entities, it doesn't move entities around, it doesn't do anything. It's just like a huge memory mapper that has a bunch of entity references, and you know, in those entity references, like what shard is running this entity, what is the entity, what's the data. And the idea is I can create as many of these shards as I want. So the shard in this case is a real Godot server that I, the player, would connect to. And these entities are entities that the shard created as an entity. An entity represents a game object, so it has any GUID on it. So quick little 8-bit GUID. And it ties itself to a game asset by whatever the asset ID would be. So we have, you know, 3 entities. Every time I create a little shard, it creates 3 entities. That's like the idea, right? So then if I go and create another one, I can run this as many times as I want, and I create another shard, right? It will replicate over UDP, the initial entity data, which is like the packet, the full serialization of the entity, and like push it. It doesn't have any relevance of whether the entity exists or not, or if the replicator has received it, or anything. It just knows like I need to push this quick, right? So the UDP side of things, right, with a token, it is literally just one way pushing. I have an entity here. Here's the change values, and whenever an entity value is changed by the shard that's controlling it in any capacity, then it'll send up those UDP packets to the replicator, and the second the replicator receives them, they're passed forward. So it doesn't verify, of course, because it's UDP that it's received the packet or anything like that. It's speed, right? Overall. So we do now need to. So if I go now and we'll just spawn another shard, right? So every single time now I create a shard, it's every entity on every other shard through the replicator will work, and this can handle tons, right? I'm literally like at the low level. What I'm working on with this is making sure that the data, like in my custom serializers, I have custom converters for converting Godot structures, like a vector 3 and a color, which is technically just a vector 4. I could kind of turn a lot of these into generics, but there's only certain types of classes that I need data to be sent that are like non-generic, that I need to interpolate values between, like a color to a color. Not that you'd actually interpolate a color, but a color would be, interpolating a vector 4 property. Interpolating a position is just interpolating a vector 3 position, like between, like at this timestamp, this object or entity was at this position, and now over this delta, it is now at this position, right? As it's receiving data, it can interpolate those, like previous values and kind of smoothen itself out without much of a cost. And all I'm doing right now is I'm kind of using a little bit of a block copy to. I want to make sure that the type is in front. So when I'm building up this little serialized data structure, which is pure bytes, as small as it can be, we're just putting the type at the very beginning. So when I'm sampling a bit of data, if I want to, I can just sample that first few bytes, which should resolve to a type, like a class type, before I even attempt to deserialize any of the data. So that way our serializer now is going to be only returning a type with the data object, and we can, if we want to, just only check the type in future. This is just kind of like, this is still going to return the object would be regardless, but this is just something that I'm kind of going to keep working on for the converters, and just to try to keep things simple. And right now we have our replicator UDP and replicator UDP client. Today we're going to do the TCP stuff. So we and I want to make a little, my goal for this week is kind of make a little demo, because there's something interesting that happens before, right? Before, what I'm doing now is I'm taking all the entities, because I either have to double the memory by keeping an entity cache for every entity on each shard to be like, this is data I need to change, because we're not using entity graphs. I'm not using a graph DB because we don't have, the way that I want to do this, I don't necessarily, in normal replication systems, they'll use an entity graph. That way, if there's changes to entities that need to change, they can adjust their graph tree, their tree. So the path to the data that has changed, and the whole branch of an object that has changed that needs to be synchronized, is a lot faster. But instead of doing it that way, I'm still doing flat hash map style. This is entity lists, but we're leaving it to the server. The server is going to be responsible for maintaining its own entities and its own entity state. and only flags specific entities as being dirty or needs update, or in this case I think it's just flagged, and any entities that are flagged on the process, on the next process, are the ones that are replicated. So the idea is like when we're thinking about UDP push, we're just like logically determining when to push on both sides. Like when data on the replicator is receiving data that can be interpolated from the old data as having some changed metric, like it is not the same. Like for some reason something has sent the replicator data and we must replicate it. Just being very clever on where we're sending the data to, and and at what kind of like throughput. So the idea is to have like this thing be very aggressive in sleeping and kind of using in future interpolation, not just as a metric of smoothing out data over a delta, but as a metric of creating like an offset, kind of a change value length, like how the server has moved this object, but maybe not enough yet to warrant kind of sending the data, to kind of like get rid of any like rigid bodies that would be like jittering, or movement and positions that are like at the floating point, moving but like not really moving enough that we should be pushing that vector 3 to the replicator. So we need to be like keeping track of position, but we need to like keep track of a kind of a delta or a length of the value change, so we can start pushing it. But then when it receives that data, when it's finally like I've moved now, but I've moved kind of a lot, right, that we can because we're kind of streaming UDP, then we can kind of like at the replicator kind of start forwarding those packets as they are changed, and then that replicator client can start bringing in these these kind of like ticks of data throughput, and then kind of interpolate it itself. So the assumption is like data flow is extremely important and more important. And so like the idea is super cool, because this is what can happen now, right? I have all these entities over here that are managed. If I start killing shards, nothing is going to happen because the entities are on the replication system. And by design, the second I run another client, like all those other colored entities, which are technically supposed to have been managed by those shards, when there isn't a shard to manage them, when they have a shard ID that's not streaming data to it anymore, then we need to mark that entity as being unmanaged. And when we have an unmanaged entity, things that are moving, wouldn't you want a position and velocity for prediction? Depends on how the data wants to be done, right? For this system, I really want to have like on the real server, the server that's doing things, all of its simulation happening, and everything would just be kind of streamed down to the player normally. The replication system is to handle edge cases where that player is no longer actually on that shard, which will be handled by the standard Godot multiplayer system. So think of this replication system as being responsible for the control of assets that need to be generated on the world, collectively within this star system, because they need to be seen, like a ship or an NPC moving. But the hope is that they'll eventually get moved onto the main shard. So it's really interpolated position necessarily. And the velocity, it wouldn't necessarily be the velocity, but it'd be the velocity of the difference between the current position and the old position. Because it doesn't want to, because this system is meant to be more of a, like how things are visualized or streamed and created on an asset level, and without, so calculated velocity, yeah, so that we're not handling, like the only thing that this needs to do, or the only thing that I hope this needs to do, is be so agnostic to Godot that like I could write a Python system, right? And all that Python system needs to be able to do is create entity objects, which are nothing but like this struct, right? This entity data, not there. So entity data. The idea is if I can create anything that exists, right? Like anything that can create this entity data struct, which has a position of rotation right now, but it can have any other data. Then it itself can connect to a replicator over UDP, and it itself can act as a shard, and all it needs to be able to do is dynamically create entities in memory, like, and interpolate them and do things, move them around, or do whatever it wants. And the cool thing is that system, which could be written in Python or C++ or anything for that matter, would still in the game be represented by whatever the real game object is, because the replicator client's job is to be like, oh, I have an entity and it has an asset ID, I must spawn it in, right? On the Godot side, and then I'm receiving like a delta of which I'm going to kind of move more into, and we're receiving these change packets of these types. I'm going to be moving it, and that's kind of cool because it breaks away, it breaks us away from the game engine, right, and breaks us away from even Godot when it comes to managing things. But I lost myself. Oh yeah. Let me show you. So I've killed all of the other shards, and I'm just going to create a new shard, and it doesn't really matter. And so what we, the idea, or what I had it doing earlier, which was great, is I could even kill the replicator, because if the shards have authority over all of their own assets that they have control over, and that is their job, the shard have the assets, then the idea is that if the replicator dies completely, and we need to assume that these will be like all pink and all blue, that at some point, when I crashed out the other clients, they would have passed authority. But what I had working earlier is I could actually kill the replicator, and all these all the other colors wouldn't update, obviously, because there's nothing to control them. But the second I launch a new replicator, each shard just literally pushes all of its own clients to that replicator, and everything works, right? As long as like the references are set. So for example, I could like shard independently, another shard independently, another shard independently, and then a replicator appears. And but the issue that's happening, because we're not using TCP yet, right, is that there's no there's no state checking as to whether it can connect to something or not. I can check if a port's open, or if we have connected, if we have sent packets in the past. But the issue is like UDP's responsibility is not to ensure that packets have made it. But I was pushing all the time yesterday, no matter what, but it was too much data. And the second I launched the new replicator, each one of these were just pushing their entities anyway, like a heartbeat, and maybe like that might be a good thing to do anyway. And everything was just restoring, and everything was working. But what I need to do instead is we need to actually create the TCP side of things. And what the TCP side of things is for guaranteeing when an entity is created, we send the entity data over TCP instead, which then guarantees that the entity exists with the entity data. And then we also need to be able to, then we can use the TCP side of things to ensure that when the replicator dies, because we actually do have a TCP connection to the replicator, then we know how to handle that, and to gracefully die and wait for a new shard and kind of connect back again, and then and work. But because otherwise, we don't really want to be pushing any data to replication unless we know, what I mean, that it needs. And the only way to do that is for it to kind of like have the entities marked as needing to be updated again, but it has no way of knowing that it's been disconnected, because it doesn't guarantee that, it just has an IP address, right, that and a port that it must send things to. So when we do the TCP stuff today, then we'll have everything. We'll have the full the full system of sorts. And I realize that that's Why is that doing? Let me go. Let me launch road connect again. See why? Because my system audio is going into the stream. Oh no, it's not. Maybe it was going into the stream because I was listening to it. No, it is. Why? Why is this thing? Just take. I try to get just like a million. Virtual input, stream input. I think it's this one. So real quick. Did I want to mute it? But I don't know. Maybe I'll get rid of it. Yeah, I'll just change it. Alright, let me just see if that's picking up the other input. No. Okay, that seems to be good. Cool. So yeah, so that's kind of like what I started working on. I didn't mean to like kind of go ham on the whole server meshing thing this early, but yeah, you know, if I can get it working in the way that I want it to be working, but if I can kind of guarantee that we have some, if I just need to create a port that exists to just ensure that they, you know, like the connections between them are established and they're not broken. But we do need like some command and control type stuff sending around the system in the first place. So that way, like when we're, you know, so that the replicator can tell the server that this doesn't exist anymore, or that this thing doesn't exist anymore. So we need to kind of work on this replicator UDP. Yeah. So TCP service. All right, so if the UDP service, could you send a sequence ID with the UDP if the client finds a problem within 100 packets per episode? Yeah, so that was the other idea, is a ping pong, you know, method, because we could totally, that's pretty typical as well in UDP world. It's like we just like, but you could literally just continuously send like there must be a pong from the replicator, you know what I mean, like after you know, like X seconds or whatever duration would be, right, or so much frequency, and then, you know, if there was no pong received, then it's assumed, you know what I mean, that we've disconnected. But the issue though is like we don't know when the replicator is back up again over UDP either, right? So we know, oh shit, we've you know we've lost the connection. We can mark the all of the entities as being like needs update, right? Which would, like, if in a technical world within that like time frame the replicator was back again, right, it will definitely push all those entities. But the issue is, once again, we don't guarantee that a shard's entities have been received by the replicator. We're only controlling when we push them. It could mark them all as needing to be updated again, and it will push them, but it hasn't been fully restarted, or there hasn't been a new service, you know, like the launch and replace it. So we can't, like, you know, we can't truly use UDP to solve it. You know, without a lot of extra new, you know, like nuances. I mean, I'm sure like I could probably whip up something, but I think I do want just you know, a TCP connection to them either way, so that we have kind of a, because we definitely can't, we can't use TCP to go right, to go shard replication shard. And the other approach that I thought about as well is to have either like a web RTC style, or, you know, even a UDP connection from shard to shard, right? So the replicator has all entities and all state, but when, and once again, it would take still some more kind of like engineering work, but it'd be kind of nice as well if the shard could figure out from the replicator, hey, here's all my shards, right, that I have, right, when I'm pushing these entity updates up, right, in a new type called UTCP. No. But if I could be pushing right to the other to the other shards directly as well, but then I'm going to create a ton of internal traffic between the shards, because we don't really know. Like, again, like, we'd have to connect to gain the benefit of pushing them directly. We'd have to connect to the replicator some way that's non-TCP oriented, or, you know, to be able to pull down you know, the list of other shards, right, that it's responsible for. So build that up so that when I'm kind of pushing entities, I could push them also over to the, you know, to the other shards that that need it. But it's easier to bounce it off the replicator and have it responsible for knowing where it needs to go. But yeah, it's going to be interesting to see kind of like where I go with it. But I think we're just going to have like a, you know, TCP client and a UDP client, and we're just going to kind of, you know, so in the Godot side, this is going to be packet peer stream. Because that's the great thing. Yeah, because it's TDP. You know, we have an existing, you know, stream that we can put our changes to and from, and we don't need to know. Yeah, right now our entities are on the replicator client for the type. So I might need to make a kind of a universal replicator client that has all the entities, and then have the two different like communication services kind of be their own class that, or I could put the I could put the replication data. I could put the shards in. I could put the entities in the shard, but I don't think I want to do that. I think I want to keep the shard data separate so that I can. The idea is we can just add a a replication client to the right to as a child of the shard, and the shard is just like really the shard is just a standard Godot server, so it doesn't know anything about this whole thing. Right, yeah, like entity syncing doesn't have to be perfect as long as there's some type of periodic validation, I suppose. That's my thought process on it too. Right. It's not like it needs to be perfect right now either. It just needs to look. It needs to kind of work in a way that kind of makes sense. Like I should be able to hopefully get this working, or I could have a different Godot server do, let's say, as a good example, NPCs. Right. So this replication server is just going to be a Godot server that spawns in NPCs and does all nav mesh movement per station. Right. So this this would just have, for better or worse, entities that literally just have a position, right? And it's like a target on the nav mesh and a position of where they are and a position of and a rotation value. So we pretty much have a quaternion and two vector threes as a example of everything required. Oh, and an animation value for if they're walking or not. But those are the properties that make an NPC an NPC right now, as far as how they're synchronized. There's a few other things, but when it comes to visualizing them, in the world, so for a station NPC, it could be kind of cool if there was a system that just created all these entities, like 100 of them, for the station, just like the main server's doing, and do all of the collision avoidance and all that kind of stuff. And the idea is that then there's just there's a secondary service that's doing all the work. It's only sending out to the replicator just those like changes to what those NPCs are doing, and that data is being pushed into the server as if it's like a level object. And it should work in a sense that we're getting a little bit of CPU cost of having to have it be a networked object and having to do some interpolation, but we're literally like on that server now, just having them move around, and clients who are receiving that information from the server. It should be pretty seamless, right? So now that server doesn't have to do any of that nav mesh stuff anymore. It can be offloaded to another server, which is going to be responsible for handling that. And it'd be cool. Yeah. So this was. Oh, yeah. I'm going to end up having to change it to, because a vote need to exist and a vote need each other, but I think, here's the server-side version of that. So let me just see, because I think there was something, so the TCP version is going to run 2301. Still need shard peers. Start shard connection. Sends our data. Receives our data and processes it. So I think I have everything here to kind of get it going in advance. And we're still sending the same data. I mean, it's still like it's just over what medium. We're still sending the same packets, the same encoded stuff. They're very similar. They're just, I need to kind of break these out into two kind of child classes of what will be a replication client. Move the entities into the replication client main, and probably put these the TCP and UDP as subnodes that reference the client by parent. So then because we really don't need to be keeping track of a TCP version of the entity data. The entity data can still just be the same. That way we ensure that we nuke the data, with the TCP connection before it gets fired off back to the server again. and that means the same thing for the replicator. Oh, refactor? Maybe we get it working before we start refactoring it all. Yeah, let's just make them reference each other for the time being. So, let's say this is going to be... Yeah, because I don't... Yeah, so I have a replicator client. And we're going to rename this UDP. I'm going to put them both in the the main class, but of the shard. But I have a feeling this is all going to be changed. But I want to get results, so we're going to. Yep, I'm just going to call this one UDP as far as its node. I'll have a timer for a coroutine. Zingris, James is now lurking. We'll kind of make these the same. Yeah, so we're going to do this until like 12, and then we're going to go back working on ship systems. So we're actually going to get fuel tanks working today, maybe some fuel scooping. I don't know, there's a lot of stuff I want to actually kind of get. We're at the time where it's time to stop, I don't know, working on like art and things and try to get some systems in place now that a lot of stuff has been kind of figured out. Yeah, so this needs to be fine. I start copying code. So we need pretty much the same stuff. Tick frequency for updating master list be same. Port in the IP address. Do the same as our counterpart. To be 2301. Yeah, because then the IP address itself and port can be on the parent class. Yeah, 'cause that's the net version, right? Now all I'm gonna do is just send the shard information instead, which we'll get from the parent. Right, this will return a pretty much a struct of just, you know, what our shard is. And we just want to send this shard info just over TCP. That's pretty much it, and replicate it over TCP for the time being. And then we'll use the replicator TCP client to check the if we've lost connection or not. And when we have lost connection, then we'll push entities over TCP instead. So we just want to get this relaying over UDP. Yeah, so this process of what's happening when it's receiving stuff, kind of going to be the same. Replication TCP is hosting, so we're receiving a message, checking the tape. And then for our data, we'll do the same serialization here that we were kind of doing before. Only then we don't need to relay it this time, because TCP will handle that for us. So we don't need to do any like ping pong, we just need to receive it, see what it is. Those will be our bytes, so we should be able to just literally do the same thing, which is receive some shard info, right? Which should be our entity serializer, and we're gonna from the byte from a byte array. We can do this for actual type object. Yeah, let's just try attempt to serialize anything that we're coming in from our client data or a packet, and then we can cast on the. That should be a byte array. Oh no. remember why I stopped working on this. The UDP one. This is stupid. Like, by default, on the Godot side, the client get data for a number of bytes, returns a chunk data, right, with the received bytes. But the issue is that the chunk data is in a Godot collection array, and not in a and not in a native byte array. And I remember like this is dumb. Right, returns a chunk data received bytes. The number of bytes to be received can be requested in the bytes argument. If not enough bytes are available, the function will block until the desired amount is reached, so we'll still get everything back. This function helps return two values, a Godot error and the data array. Oh, maybe the collection array is the error and the data array. Oh, wait. Wait a second. We're returning. What are we returning? A read buffer, bytes, byte total true. Yeah, so I have a feeling the array return is only because it's grouping the error. So that'll be a native array, but I think it's a native array. So yeah, so it's the total bytes in the stream, the bytes itself, and the buffer. Let me grab it from here. Reappear TCP. The object. Yeah, I want this method in the CPP file. Stream peer extension, get data array. Where's the break between these two? Put data, put partial. It should be this one. Yeah, what is this buffer? Like one in the array is one I want. Let's return an error. That's the issue, is we need to return this data. This is not necessarily a packet. It's let me actually, yeah, let me see if ChatGPT will help for a second. I want to see, because it might just be that object. Right. So it might be like where, or you know, we do like error. Alright, get data byte. Because it could be like error. Data. I think it's like error. Can't destruct into assembly method. I want to see how it's doing the error handling. I have a feeling it's pulling back an error or an array. Hey, what? Get available bytes. Oh, what? Why did I get data for the buffer? Right? So we create the buffer. Oh, because it's a native array, so we put the length in advance when we get available bytes of the string, and then get the data passing the buffer. And then we'll have our buffer. This didn't work though, because of that return type of get data. Right. Alright, the data is converted from bytes to a string and printed. Yeah, that didn't work though. If the available bytes is greater than 0 on the client, try create the buffer array based on the available bytes, and then pull the data into the buffer. But this doesn't cast that way as far as I know. So if bytes, I guess we don't really, yeah, we can just check and see if it's available. Yeah, so it's if, alright. Yeah, bytes are greater than 0. Let's just assume we know what we're doing here. Because that didn't work before. I mean, I wasn't doing under a try, but this didn't do client get available bytes, so create a buffer. There's no way it's that easy. Just do client, get data, and bind it to the buffer, and it works. Because it won't, because the return type what did that change? It's okay. That's what I hate that it's a Godot. I don't know why that randomly changes. My light. Do. Right, like this buffer, which is right. This is our int. The buffer is a byte array. Our client get data. See, it wants an int of how many bytes to get, right? Which is what this is, right? Client get the available bytes. So creating a buffer to the array, right? I get that we would feed it, right? How many bytes are available in the string. We feed it to get data, but this return type is a stupid collection. It's not in any of the documentation. It's not actually returning. Like, I guess I could iterate over the function and watch it, see what the return type is or what it's cast to as a var in the debugger, but I like that doesn't work. Yeah, get data, take a int, right? 4.2. Let's just find like a better example. So we can feed it the buffer and the available bytes, or is that just messing up because it's like thinking that I can? No, there's literally there's only bytes. Why is the return type of chunk? Right, why is it just a collections array and not just an array of the data that I want? Right, because Indian, this is already done. put the string, UTF string, get the string. Yeah, it's so dumb. I hate it. I'm gonna just go through and so this is our. So let's see what the types is when we get to this point. That's when we receive anything in the replicator TCP, so we probably won't receive anything right away, but we'll go ahead and send something anyway. Look at some shared information. Is that a single one? Oh. Data. So just send that, right? Grab our shard info and just push it, the data itself. Right, blocking all necessary until data is done. Function returns an error code. That's what I mean, like the return type is an error code on put data. And same thing with, I wonder if, let me change this. Right, because I have this. Which I'll change here. Let's put this one, same thing. Only we'll do TCP. And we'll still. Yeah, at least we have a lot of options of what type of data we can put, though. I do like. I just gotta figure out how we like the receiving. Like, how do we know what type of data is received and how to process it? Right? Because it might just be like we had to cast. Like, it's gonna be like, you know, client that bit. Is there a get type? Because I know we can get all the things to get us like the last. Or we can send them, or we can get them, get assigned value from the string. Maybe we can get a string from the stream. right? Gets a UTF-8 string but byte length from the string decoded. So it seems like the process is to just send it. You know what I mean? As it's typed with the put, and then we had to check. How do I check this type on the receiving side is the issue, so that we can then request the correct getter. Right, like this can put an entire variant over TCP, which is great. You can literally just push an entire object. Right, full objects is true. Put the variant into the stream. If full objects is true, the encoding object will allow and potentially contain code internally. And then what would the get bar be then? Would get bar return yeah, I wonder like if we don't even need to do our own serialization for this. Curious. What happens if we just literally put the shard info directly? Oh, but it's not a variant. Shard info uses actual enums. No, it doesn't. These are all variant compatible. String int. I still want to get data working and do our own data. But I'm actually curious to see how that works by no, because shard info would have to be a resource then for it to work. So shard info resource. But I could make one, just to see if we actually get a shard info resource on the other side, because that would be cool. That's wild. So we can just use like a dev object. Or they'd having to create like a serialization system. And then technically on the receiving side of that, when we're going through our connections and checking our receiving, if we have any bytes, we can just do shard info resource. Winsands is lurking. And it'll just be get var. This type of variant cannot be handled by a pattern of type card resource. I mean, it lets me define it because it's a resource, literally. They won't let me cast it. So maybe it's just simple. Maybe it's only basic variants or basic variant types. Cool objects is true. The internally uses the same methodology as global scope bytes to var method. Deserialized objects can contain code. Yeah, we're aware. Right, so we can just send there's no way this works. It's so bizarre. That I can literally send an entire... that its internal method supports just any particular variant as a Godot object. The whole object. That's a lot of data. Alright, I'm gonna, yeah, so it's to create our client, we're gonna connect. We're gonna keep sending shard info resource from the shard. We'll see if it actually pushes. Shard connected by TCP, but hasn't done anything yet. I don't know why people would buy viewers. It makes no sense to me. Yeah, so we're not getting this push that's supposed to be happening. Right, so the TCP is hosting on 2301. Hmm. Oh, the timer's not defined. In the shard. If this works, man, this is going to be amazing for what I can do with this. Like if I could push an entire variant over the network securely. But I'm definitely not... I'm still going to design my own system for this. Even though there's a lot of power here. Oh my god, wait, so it's trying to push replication. But I'm not seeing, so we're definitely trying to push it. But whether we're sending this shard information, I don't know if I don't think we're receiving it. Okay, so that's working. Does put return an error if it doesn't put? Like, when we do put, do we need to do anything else? Do we have the poll? We have a TCP stream peer get status. But I think we only have the poll on server side. Is my understanding. We only poll. Unprocess. Set shards. which, if there's a new server, it creates and there should be an report. Yeah, I think on receive message. I don't know if we have the call the. Maybe we have the poll before we get the bytes. What is the get status? What's our return type? It is. What is this? Godot.streampeer.status. Oh, stream peer TCP. Oh, okay, just connected. Okay. So we can check to see if we're connected. We can check to see if we're connecting. We can check on an error. Oh, okay, so that's good, that's good. So we can actually check and see if we're still connecting yet while we're trying to update. So in other words, if we're still connecting, don't change any entity. Yeah, so it's connecting, connected error 9, I just... Notes. Yeah, there's a connecting, an error, and a none. Be right back. I'm gonna quickly use the washroom. Ah. Yeah, so we get shards. You can send messages to the shards. But I don't know if we're actually receiving anything. I don't know if this is actually being called. Yeah, this is not. This doesn't show up. Yeah, like it should be able to receive the message from that pier. That this should be working. But it's not. We need like a client status. Maybe we need to create like a debug that kind of iterates through different shards and shows what they're doing. Let's see if there's an example. Oh, I didn't mean to pick the one. Yeah, once we have a client that is connected, it only has one. Right, for each of the peers, we should bind the peer array peer to the connection. And check if the client is connected to the host. Get the available byte. Once it's greater than 0, we should have the message, which should get cast to a variant that we receive the data. And this is pretty much, I mean, this example does not have a group of clients, but it's the same code. Right, so if we right, so our client's going to be the server take connection, and then we're adding that client to the shard peers. And then on process, we're going through our shard peers, checking if the data length, are we on process? We should be accepting new peers. I'll accept shards. Yeah, accept shards. Yep. And then for each of the peers, we're getting the available bytes. And then just sending the peer to the receive message, because that'll be the client. Right. Client has data. Client has data. That needs to be processed. But it doesn't. On the client side, we're trying to push it. We have both connections established. Do we have the poll? What? Oh, how warm it is. I do not understand why this is not working as per the example code. Because even if we were to push a string, it's like, regardless, we should be, we should have some bytes. For the client. Yeah, let's run the replicator client. And let's go through this process. Run just the replicator. So that we can watch. So we want to watch on the shard peers. Okay, so we want this shard peers. Okay, and now we are going to boop. run one shard. I just continue forever. Mm-hmm. Yeah, so I have one peer in Little Indian, and the return type here, we go forward. What do we get? Nothing. Right? Do we have to poll each client? Yeah, because obviously I'm getting the connection. I don't know if we have the poll. I don't know why. The data that we're pushing, even though we're connected. And we're definitely connected. There's the peer. If we go through them and I just say, hey, there's no data. Right. Right, there's no data. We should just get a total spam of no data. With one client. Even though it is trying to push it. Right? What am I doing wrong? Ugh. What are we doing? Do. Yeah, what we just need to understand how this TCP library works. Remember gold on it. Why is there a poll on it then? Get available bytes is greater than 0. Try to do the thing. See, there's no polling here at all. There's literally only a listen on the server. Yeah, so let me look along this. Yeah, make the client version. I want to see what the client's doing. Right, we are connecting to the host on error. We're checking if we're connected. We're building up our variant. We're putting the variant, and then that's it. Right, which is exactly right, and this will be a string. Obviously, this could be any particular data. Oh, the client does connect to host. Okay, hang on. Let's just kind of double check here. On our client, let's close out the C# code or C++ code. Let's check our client again. So by default, no longer. I'm ready. Okay, so we could, yeah. Let's do a little bit of error checking here. Oh my, come on! What are we doing? Why am I getting no methods? Hang on, let's restart. Relaunch the project real quick. Okay, so replicator client TCP. Let's make a connect function to handle this. And we'll do kind of the same thing. So our stream peer is going to be new by default. We're going to connect to IP port. Just to make sure we're actually connecting to it. And we'll set up our timer. And we'll check if we're connected. Yeah, so we're trying to push to replication. Okay. TCP is connected to host. Connected to host. What is the default then? Oh, right. It's the whole get status thing. Yeah, let's just see if we're actually connected. We're not connected. Ba-da-ba-ba. Yeah, so that's why we're not actually pushed, because that's not actually working. There's a shard. Yeah, so this connect the host should actually still be correct. But get status, so like what, when we're trying to push, let's actually see what it is. Just run. What do we say? So like we're so close, but yet so far. It still says we're connecting. So our status is still connecting, not connected. Are we blocking the port? Do we need to like create a new port for every client? Like it said that we were connected. That's the crazy thing. Like we were connected. But it says we're connecting under client status. But we literally like shard connected to replication at 127.0.02301, which is what we're binding it on. Right, TCP hosting waiting for shards on 2301. Right, the shard gets created and connects to TCP and binds to its own random port. You need a poll, by the way. I do need a poll. Is that the issue? That's what I was thinking this whole time. Oh my god, that we do need a poll for the client. I swear to God, if that's... If we need to poll. So like per... Yeah, so on the client we'll poll. A replicator, a shard, a shard. Oh! Poll can return error. Yeah, no, it works. I'm in the variant for process node, process server. Yeah, okay. Thanks. Should I send my invoice to the usual address? Of course, you know, to be paid in promises of a game in 14 years. So like, I've been digging into this, and it's interesting. Like, I would not use some of this stuff. Like, I went through this whole process of, on the UDP side, of building like an entity serializer. I love this, right? Like that literally. So that has these kind of like, you know, converter types, right? And the idea is we convert, you know, to pure. We convert very basic structs or classes, and that we want to send into binary. And then what I'm doing is we're putting the type at the very beginning, assuming that ordering and stuff is, you know, a little Indian and everything is great. We get like this really... Do you already know about message pack? No, I don't know about message pack. What's message pack? This is like a day and a half of development. What's the MSG? Oh, what is this? Mrs. Back for Elixir. Oh, look, it's doing everything that I wrote. What does it do? Is it just doing is efficient binary serialization format exchange? But it's faster, smaller indicators go to a single byte. Typical short streams only require one extra byte in addition to the string itself. What's the spec? What are some of the limitations? Max length of binary object, 2 to the power of 32 minus 1. Max type of string object. Some objects may contain valid byte sequences. Deserialization should provide the original byte array so the application is going to decide how to handle the object. Oh, so this is literally doing a better version. Notion of datagrams, 1 byte. It's like protobuf, but without the fields. Apparently I was wrong about the fields. Yeah, hey Munglo. Float family friendly, stores floating points in 5 bytes or 9s. Cool. Let me change the sign. This part of the track is dumb. We'll put on the other one actually. This desert one. That is going on. The I'm gonna throw that in ideas on the Discord. So there's a bunch of these. Is there a C++ version? There's many of them. Yeah, because I want to think about trying to make sure we're only using stuff that we can kind of move the C++ if we had to. Kind of like port it. Like if we want to just kind of go a bit more native and kind of like switch things over the GD extension. This is awesome. Cool. Okay, so what were we doing here? This is received, but no data must be received. So we're just trying to push mission. Alright, so we just gotta pull the client. We have the client full as well. Mm-hmm. $84. Gets a variant from the string. If allowed objects is true, the coding of objects is allowed. Have you tried pushing like resources over the network before, Dev, did you? I've been playing around with some of these things that we can and can't push, just to kind of see what they are. In general, I didn't do much, but good. Okay, I gotcha. Yeah, because it's really interesting, right? Like I started playing around with what, like on the UDP side, it's much more like you have to do everything yourself. But it's kind of weird that there's kind of a yeah, like you can poll, get our status, we can create anything and put it. Like they're literally, right? We can literally put anything, including a variant. Let me just do something. Let me send a high on the string and grab a high. Because how do we tell what type of data? Like, you know what I mean? If we can get these things, there must be some server receive this random string after we poll. Yeah, it literally is. Literally, yeah, it works. Like it's so weird. You know what I mean? We just kind of like loosely. Right, so we're getting high, so we can send anything. But I want to. And what's our error here then? There's a bool I'm trying to decode. On a stream here, so on a replicator 91. Oh, previous code's still in there? Okay, okay. Oh, yeah, right. With a variant, it could be null. Let me just check with the object. Yeah, no, variants can't be null. Does this... It's so weird. And I guess really we just got so because we could totally do like if the object is right, like these are all the variant casts we could do, right? Like as a Godot object, and maybe we just can't cast to. Wait, do we have a resource? As a vector 4, as a vector 3. I like that we can actually push transforms over it. And interpolate them, but as a rid. How does pushing transforms work? Do they sync every transform or only the network objects? It's just literally the pushing the transform. Gotta handle everything else ourselves. Wait, as a color array, as a callable. Yeah, it's so meh. As my resource. Oh, I just saw that. That'd be like if this works, this would be so cool. It's not valid which given context. Actually, let's say if is, or does this actually evaluate? Can we do like no, let's see. Wait, is transform in this context is a matrix 4x4? I'm pretty sure. It's just a standard Godot transform, which would have everything, which should make it super easy when it comes to replicating positional data, and even maybe even interpolating them if Godot, because I think Godot actually has a transform 3D. Just hang on. Thing the transform 3D dot. Oh. Yeah, we can actually, yeah, exactly. We can actually interpolate transforms, right? Over a delta. Or over a weight, it should say. Assuming we have both. Right, so that means scale would also be honored. So technically we could, you know, just literally stream transform 3Ds and kind of like cache them and kind of just interpolate with them over a delta. Yeah, the weight should have been like named percent in my opinion. Yeah. I mean, weight as percent makes sense. So that's totally possible. And just to show, just for Etrium, who's just kind of joining in, I'll just kind of show you what I got working here. This is all working on the UDP side of things, but what I'm trying to do is we're going to get the TCP IP side of things working so that the replication system can actually communicate effectively with the shards. So the idea is we have like a replicator, and we can spawn up. Every one of these shards are like Godot, you know, like servers. So I spawn one, by default it creates 3 entities and it syncs them to the replicator. So every time we create a new shard, it just creates 3 more, right, under its own authority. And it can spawn in a few extras, it doesn't matter, and they replicate. But we have like these different shards. Now, at any point we can kill any of the shards. And just kind of like run anew here. Let me actually run the build. So like, let's say we have a replicator, and then like shard, then another shard, and then another shard, and then we, you know, here they all are. Then they all died for some reason, and then we run another shard. Right, all the entities are still. Are you planning to have like a dynamic tick rate? It depends. Right now, the server is really just doing things on just a process, and I have a specific timer defined for how updates are pushed. But as far as the relay is concerned, whenever the data is pushed through UDP to the replicator, it's relayed. So as fast as shards themselves want to push data, the data itself will relay, right? But it's going to be like a lot more, you know what I mean? Like things are going to need to be a little bit more advanced than what I would have created in a day and a half. But I'm going to keep working on this on the side of the project, and the goal is to be able to put these in as a middleware, kind of because we still have one main Godot server on the shard controlling all of its clients, and I want to use this to be able to create another server that spins up to control entities that are like NPCs, and it's mostly for effects interpolation implementation. Yeah, because we like the idea of the replicator client is when it's receiving data for the entities, it will do interpolation, right? So it has to, because we don't want to. I actually want to have a kind of a vector length of a change of data. Like we don't want to be syncing position of all the entities all the time, because with 64-bit precision, there's a lot of jitter. So we really need to like only push to replication, like if the distance that the entity is moved is past a threshold. And because we're doing it past a threshold, that means there's gaps, you know what I mean, in movement that must be interpolated anyway. So we have to stream in, say, those vector 3s as doubles, and we have to interpolate them on the replication side so that it's perceived as being kind of, you know, clear. And that's just because I don't want to have a ton of data. Like I want to make sure we're only replicating data for entities that need to have that data, as far as how the player perceives it in the experience of seeing other things that are replicated, right? Because they themselves are not on that other server yet. They can only see what is replicated to them until they are finally, you know, moved over to the new server and are able to kind of, you know, interact with the world in a more physical sense, right? Whereas what is replicated is really static and only perceived to the player, as per the implementation that I'm going with. But all we need, like, so that the interim right now goal is to get TCP working in a way that I want the shard to know, because right now we're just pushing one way, right? Entity data, and we don't know if it's received it. We don't care. We don't want it. We don't want any callback. We just want to like, oh, data. Oh, I got data, and it does its work. But we want to have a TCP connection that kind of works as a bit of a chaperone type system, where the TCP connection itself will also authoritatively send the entities. So we have a true guaranteed entity synchronization of the entities itself. Like when it receives data of an entity, regardless over UDP, it'll assume, oh shit, we need this entity, make it anyway, because we can't trust 2 ways of a TCP connection to kind of do ack, you know what I mean? Like we just want to like, oh, we have data, make the thing. But we still have authoritative updates that'll need to happen over TCP from the replication to the shard, as far as asking that shard to take over control of an entity. Because when 2 shards are running and we kill a shard, right, the replicator needs to tell the other shard, I have entities that are not being controlled by you, I need you to make them, right, authority, and I'm going to set them as authority. On your shard, you need to set them as having the multiplayer authority over them, so that shard can then be the one that's pushing the authoritative updates of it. So as they're dying and new shards are creating, the replicator has TCP authority as far as the communication it's sending to tell, the shards to distribute these entity loads and actually make sure that it's in sync. So that way it also knows that the replicator has died. So when I create a new replicator, each shard knows the connection has been lost and it can push authority back and push all those entities back to the replication. So the only way the system can die is both replication and every shard has to die. As long as one shard is alive, right, the system will work. Aviate very slowly with way too much overhead. So we still don't really. Oh yeah, right. So we did the thing. We removed the thing. Let's actually see. Yes, we're receiving our high. Man. I'm reading through my own sync and holy crap, it's a giant mess. I'm very much trying to not do anything that I would consider would affect the performance of the game, even at whatever the cost would be, to not have things only simulated on certain shards. And I'm hoping that it works, because it has to be ultimately at some point production ready. It needs to work, and I need to be able to extend it in some way. So what's the error that we're getting now? 91. Oh, this didn't work as a shard resource. I don't really care. I'll change back the data and we'll do our own serialization and deserialization just like we were doing before, now that I'm polling. Because we should be able to literally do exactly what we were doing before, now that we know. And so I'm going to... let me just go and see if I can use the old methods that we were using. So on the client, let's actually go and use our earliest resource. Let's just send our shard information with our own entity serializer. And let's just put the data for the packet itself, and then let's check on the other side if the what was your game, Unreal, Ephraim? I don't remember what you said your stack was, or was it Unity? For Unity, cool. Yeah, so let's packet your byte array, push it raw, and then let's check if yeah, let's just do the same thing. Just do data is going to be, we're going to get data this time. Oh yeah, right, because that's a stupid thing. We still get a data must return an error. This is the issue that I have, right? Is when we try to do it like we did in the UDP way, we get back a collection array. And I think this collection array is actually, because I looked into the C++, it's an array of error. The data itself, no, it's like error, the data, and I literally just need the bytes. The number of bytes we like to receive. So, because we should be able to just literally, yeah, I don't know why it's being so stubborn. Right, if the available bytes is greater than 0, then the data should just be our available bytes that we're requesting. Right, this should return, but the issue is this is now a collection or an array. One other thing I'm trying to keep around was like a dynamic tick rate. So there's a lot of players in a specific spot. You can send this data frequently, but all interpolation and prediction code handles it somewhat well. Yeah, that's very similar to how I wanted to do with players that are in like areas. I want to create like kind of like network LODs that work on the premise of area 3Ds. So kind of like, you know, if you're in an area 3D in the world, or if your actor is in like an area 3D in a world, right? Then, you know, like these area 3Ds kind of control, you know, the different types of interpolation and different types of data. Like I always explained that, like I want, you know, two players that are playing a pool game, right, to be receiving those rigid body positions at like a really high tick rate, maybe interpolate at 30 or, you know, vice versa. But then outside of that pool table, you have players, and those players are observing the pool being played, right? They're not actually playing it. So a lot more interpolation can happen there, right? Where it doesn't really matter if what is happening is kind of perceived as being in the past, right? Because they're not playing the game, they're just watching it be played. If it was like a second of latency, it wouldn't matter to them, as long as it is interpolatable. And then like outside of that area, you know, if a player was in a club and they were looking over at it, they might see like some, you know, kind of 15, you know, FPS kind of like reflection of kind of what they're perceiving in the area. Right, but it's one of those things that you just gotta, I don't know, make it and see what happens, see if it works and doesn't work. But I do want to get LODs, like network LODs, that work based upon physicality or the understanding of, you know, where, you know, entities are, or where a player is. Because I think it could be useful. So as didn't work. Still think, because when I'm, yeah, like what is this? Let's break here and see what this is. Because we will get a client sending it. Because if we can serialize that data and see what it is, even in this kind of binary format, yeah, this will just be normal. I'm just curious. So let's run one. Let's launch a replicator by itself, and then we'll connect here with the client. All right. So I just want to see what we get here. All right. So let's run one shard, and this will. Okay. So if yeah, so let's kind of step through this here. So the data array oh no, it actually is. Yeah, no, yeah, it totally is. So how do we convert? This is the issue, though. Hang on. Of all the issues I have now, the train and rendering is what's holding the progress down. I gotcha. So this is my issue. Why the Godot array? Oh wait, hang on a second. There is two entities in here. Right, so what's 0? The data is the second, and the error, oh, it must be error data. So this second part of the array is definitely the data. So what is the first? It must be the error code. This data, get data must return. That first data has got to be the enum of the error type. right? Because that's definitely my packet. By length. Let's see. Yep, no, it is. Okay, so yeah. So it's our P buffer and our byte buffer. And we got a P buffer of 0. Right? Get available bytes. If our fatal function get available bytes. Get data in raw. There's our bytes. What is our P buffer? Right. Oh, I wish the documentation was better. Returns a chunk data. The number of bytes to be received can be requested in the bytes argument. If not enough bytes are available, the function will block until the desired amount is reached, and then it will return 2 values as the Godot error code and the data array. Okay, so that is the Godot error code. And this should be a native byte array. Why is it so convoluted? Document the things. GCP has literally, like this, like the low level stuff in Godot, even on the C# side, is literally no documentation. So that's what it is. So 0 is the error code because there's no error, obviously. And if the packet was split in half because it was too big, then we probably just get, you know, error code 1. What is the error code? Where's the error code list? We'll just give an error code. Blah, 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 blah. So how do I do that? How do we... I mean... If it's a Godot collection, that array data dot anyway, let me make a note to myself. Is there a byte array native? There is! Yeah, it's annoying. And we should have serialized it normally. So this should actually receive now we can use our normal chart info. Chart info, and we can actually just use our serializer that I wrote. Entity serializer from byte array. Casting to a shard info of the bytes. Oh, yeah, we don't do that. Oh, right. Okay, it was in there. Okay, so if object is shard info. Do that print, we won the game. And then we're going to ID. And then mystery solved, and we can just use our own serialization still. Because I can actually just type check here instead of casting. So it's a bit faster, but let's just see if we get shard information sent as raw data. And then we can kind of do our own thing with it, without having to pass objects and variants and things around. Replicator, shard. Deserialization failed because the offsets and let spread of bounds for the array count greater than the number of elements from the index. So maybe we're not perfectly. Oh wait, hang on. This is still coming out as a data as the second one, not serialized. Yeah, and that's because I'm an idiot. Actually, I see data one. Am I printing over the data? Here, let the data. Oh, that's good. Maybe this is not. As a byte array. Data one as a byte array. Maybe it is. No, it's still variant. Maybe did I print out bytes? Your byte array, baseline sharding. And we're putting it. It's putting data based on this info that we're getting. And let's just get available bytes. Nah, that should still be fine. What are the area codes? Really dot. Oh, it is error.ok. Oh, okay. So, but these are the enums for the error codes. What are they? Okay, failed, unretrievable, unconfigured. Okay, I gotcha. Yeah, so we could actually check, make sure there's no errors. Ooh. Okay. Yeah, this is empty. Cool, get the status. Grab our info. There's a shard. Might not be. Right, you know that's working because it's being put. Yeah, because it has bite, or it wouldn't be getting this far. Why are you from bite array of bite and not her? Hey, Daz Razor. Why am I from bite array as bite, not shard? I don't know what you mean. In line 99. Why? I don't know what you mean. Why am I deserializing the values? Why are we not? What was our no data? Where are we getting no data? Okay, so we know it has data. Let me see what the length is. And I wonder what the difference would be. Oh yeah, so it does work. Cool. Yeah, so now I don't need to worry about any weird serialization. I can just use my own serializer for everything. And then check on the... So we are now getting our shard data be sent over TCP as well. Now we just need to be very clever with the control of the... Well, it's not yet. I need another way of just pulling down the type. Do 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 do. Yeah, so let's see. What's the next? We should actually clean all of this up. Pull our data. Client data. Assume. Can we do like this? Can we do like error? Error. This is a thing like, yeah. Or doesn't have a destruct option. This one is destruct. If you're packing a shard to byte, why are you unpacking to byte? If you're packing a shard to byte, why are you unpacking it? What do you mean? On the server side of it. So the return type. Hang on. I'm just trying to create. So the data that we get back here is a Godot collections array, where the first one is the error code and the second one will be a variant that turns into a byte array. That byte array that we're getting back from the data, this is just being deserialized. We're coming in from the byte array, which turns it back into a class. Make sense? Just this return type of data, I just want to pull the second value of this. So I'm just trying to clean it, because I'm sure we could do like this, like I'm doing here, with the data, and then like check out the like maybe that, but then we still have to cast it, so it's still kind of, you know, we could do like error data. Hang on a second. But it's saying that the array does not contain a definition for destruct, so we can't destruct. Because this is still going to be another variant. unless I'm using data somewhere. I'm not familiar with type. Does it hold info required to understand the bytes? Well, just the bytes is the second one anyway. Like if you have something like my serializer returns a kind of like a tuple of type object data. I'm just trying to like bring this up so we can error check on it. Because the return type, right, is a collection, and that collection contains an error code and the data array itself. So I'm not sure the C# way of kind of like just without just calling 0 or 1, of just kind of casting it correctly to its native Godot error and native byte array type in like a single line. But it is clean. Yeah, this. Yeah, there we go. Right, if the available byte is greater than 0, pull our error. If the error is error okay, then we're fine. Then we can type check, and then we cast, and then we're good. And this way we can actually put our error on the receiving of the data, it not actually being being chunked up. Just so it's a little bit cleaner. But I don't know why it didn't work actually when I changed it earlier. Oh yeah, why does array not have a? Oh, we're not using collections, right? Maybe it's because we're. Oh. Maybe it's because we're using generics, not the Godot array. How would I use that for the edge case? If you're data. Because we can't infer. What does it hate? Looked interesting. So doing that, you can pull both the error codes and the data. Yeah, that's the idea, but the issue is that we're kind of using our we're using standard collections for lists for our shared peers. But when we're kind of like getting into the serialization, because Godot's collections are different, that's the issue, right? Godot has its own collections library. So, you know, I could change it to, like, you know, so that our list of peers is technically an array instead. And then we could kind of just use the Godot standard for it. It'd still work. I say that, but it still doesn't seem to... Are you missing the assembly definition? No? Right, then if our error is okay, like this is, we're all good, but how do I copy this one error without it problems? Copy missing. Curious of why. Because it returns a byte packed array. Yeah, and because it's a packed array, and we had to run 2 array, yeah, so I still gotta do it manually. But pulling the cloud, yeah, I know what code does. Can't take it quiet. The way that I want. Anyway, it's fine. So we can error check here. Can I force cast it to an error? If it's going to be just a none? Oh, I hate variants! Hate variants, man. Right, it's so annoying. That could just probably be as standard in. Yeah, whatever. Yeah, because then we gotta do like if error is okay. I hate it. It's so messy. Certain Godot things drive me mental. Either way, whatever. We know 0 is the error. We don't have an error. So let's see. What's next? Now that we know that's working, now we can kind of go through whatever we wanted to see and cast it and see what type of data it is and do something with it. Yeah, so we really just need to see if we're connected. So we need one to have a reference of the other. We need this to have a reference to the TCP client. Okay, so this going to have, or our UDP client. We want a reference to our other replicator UDP here UDP client. And we'll just do set and get private set. Because we're going to refactor all of this. But I just need to, from the UDP, we just need access to the TCP client. And I'm just going to set it in the inspector. Because it's going to use its TCP client to determine state to the shard. Just so I know if we've disconnected until we've connected again, that we can kind of like change our entities and push them. and that'll be because we're supposed to end this. We're supposed to end working on this and go back to the systems, but because then on a process on our tick, we're updating replication. And we're pushing entities. Alright, so for push entities, we are going to check if the TCP server is connected to host. Right. Yeah, okay. Let's export. This was private, but we do need it now. And 60. Alright, so if our status is not connected, we are going to set all of our entities as neat. Okay, so we're going to set. Alright, so we're not connected. Replication max. Which means immediately set entities flag. And this will automatically Push all entities that we do control to be flagged. So we'll set all entities to be flagged that we control. So it forces them to push on the next update. And then we're only ever going to push entities yeah, it doesn't really matter. We can just return. So we're good to go. So replicator, shard, kill the original replicator, create a new replicator. Oh yeah, but we need to actually wait. We're still lost. We gotta force it to reconnect to the new replicator. On the TCP side. I wonder, can we just help try reconnect again? So if we're lost, and then do CP right. Yeah, because it is connected. Connected to the host. No. Fine. Yeah, we'll do reconnect. Because I have a private one, right? Okay, let's make it public. So all while it's lost, keep flagging them and try to reconnect. One replicator, one shard, another shard, kill the replicator, create a new replicator, works. So the only way that it can be totally killed now is if they're both dead. So let's try to create something already in use. Yeah, that's fine. Let's do a build. Sure. So I had so technically this will be super cool if this works. We're still not changing the authority and we're still gonna lose a shard, but what we should have now is a replicator that works on both TCP UDP, so a shard, a shard, a shard. I'm going to kill replication. I'm going to relaunch a new replication server. And now I'm going to load a new shard. And it works. And now I'm going to kill all of the shards with only replication. And now I'm going to launch a shard. And maybe another one. Okay, so now we have a lot of little nuanced stuff to do, but that's totally fine for now. Because we need to, I need to make it so when we kill the client, we get a notification of disconnect setup, and then we tell the replicator to change the entity owners, right? To divide the entities amongst the shards that are kind of active and not disconnected. So we need to know that it's been disconnected, client. And then that's all it should have to do is change these ownership, change the shard ID, and I'll make it kind of change the color just to represent what shard that it's on. And yeah, and then so I'll get that working probably this afternoon, and then we'll start like moving some of the stuff around, like actually pushing the values themselves. So I want to create another UDP packet type that just has a entity ID and a value type. So whether that entity, position, entity, color, entity, and then kind of like, we'll go from there. Well, that's it for just this early part of the stream. You can check my uptime. 3 hours, okay, yeah. So I'm gonna go take a break, maybe go raid someone. And we'll be back probably after lunch. And I'll try to get the rest of the stuff ironed out. A few more things I gotta do. But straightforward stuff. Lots of edge cases we need to take care of. And if you guys are enjoying the progress, check out Discord. And of course the Patreon of the project. And let's go in and end it here on YouTube.